that. Screen off.
There we go.
4. So borrow a pencil. Sure. Thank you.
Okay. So today we're going to be doing a little bit more factoring. This one's going to be about difference of squares. So we kind of did them without really talking about what they were before when we were expanding. So it's just a special kind of way that we can quickly factor stuff. Okay. If I ask you to evaluate or just like calculate each of the following, what do we have? Perfect. So the square root of 25 is 5. Square root of 36 is 6. And the square root of 144, 12. Perfect. Okay?
Square roots.
Yep. So if you know them off the top of your head, that's great. If you need to punch them into your calculator, that's fine too. Okay? But they all work out to a whole number. Okay? So it's exactly 5, exactly 6, and exactly 12. Okay? So these are whole numbers. Okay? So whenever we use difference of squares, we're going to have whole numbers. Okay? Oh, the other thing I want to talk about, these numbers, the 25, the 36, and the 144, we call them squares because 5 squared is 25. 6 squared is 36. 12 squared is 144, so these are all squares. So when we talk about difference of squares, we are subtracting the squares. Okay? So first thing to do is check and see if you have a binomial with a subtraction sign. So it's important that they're subtraction. In between terms are both perfect square terms, okay? So something like 25 x squared is also perfect square because it's x times x. You could have 4x squared because 4 is 2 squared. X squared is x times x. Okay? So these are all perfect square terms. Okay? So you can have a number by itself, a variable by itself, or a number and a variable together. Okay? So we do our final answer in the form of square root of the first number minus square root of the second number times square root of the first number plus square root of the second number. Okay, so our answers are going to look kind of very similar to one another, just once we're adding, one subtracting. Okay, I think it'll make a little bit more sense once we do one and do it. What we're actually looking at. Okay, so we want to fully factor each of the following binomials. So the first one is x squared minus 25. So check and see what the square root of each of these are. So the square root of x squared is just x by itself, okay? So the squared and the square root kind of cancel each other out, and you're just left with x. Okay? So the square root of x squared or y squared or any variable squared is always just going to be the variable by itself. Okay? Then I want the square root of 25. What's square root of 25 again? Sorry? 5. Perfect. Okay, so we have a whole number here. X by itself, we consider like a whole number. So then our answer is going to look like the square root of the first number. So let's have x minus the square root of the second number, 5, times, sorry, it'll be x plus 5x. Yeah, x plus 5. Or, hey. Yep. Yep, no problem. Thanks, bye. Just with student services for a minute, buddy.
Student services is,
Yeah, if you go like kind of all the way down the hall, then down and down the chapel for me. So we have x plus 5 or x minus 5.
Oh, yeah.
X minus 5. Okay. Okay, so if you're looking at that formula from above, this was the square root of the first number. Square root of the second number. Square root of the first. And square root of the second. Okay? But all you want is x minus 5 times x plus 5. Okay, so it might seem like kind of like a complicated formula, but it really works out something pretty easy. Same two numbers, just subtract and plus. Okay, next one, B. 36x squared minus 49. So we want to check square root of 36x squared. Cares?
6x.
Perfect. So square root of 36 is 6, and square root of x squared will just be x. So it gives us 6x. Okay, so we do square root of our number and the square root of the variable both. Okay? Then check square root of 49. Square root of 49 would be 7. Perfect. So 6x and 7. No decimals, they're all whole numbers, so we're good to go. So this will be equal to 6x minus 7 times 6x plus 7. Okay, so once we get the square root of each of them, we're good to go. Everyone okay with this right now? So it's always just going to be two terms. Okay? So two numbers with a subtraction in between them. Next, a squared minus 1. So check, the square root of a squared, just hit square root of x squared, it's just going to be a, perfect. And then the square root of 1 equals 1. It's also 1. So even if you want to kind of set it up like this at first, you know, one's going to be subtract, one's going to be plus. Then put in your first one, a, then your second one, 1, and 1. Then a minus 1, a plus 1. Okay. Try D on your own, and then we'll move on to common factoring out first. Okay. So try D first. Make sure we're all on the same page. Remember, so something plus something, and something, sorry, no minus, something plus. But really, if you write the other way, it doesn't matter, because multiplication. Oh, so just be understood. The square root of 49.
Oh, yeah.
Yeah, perfect. Yeah, so everything else is good, so just change it to 49. Just be right. Yeah. 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 Yes. Like it doesn't matter if it's plus, but that's what the minus. Okay, so good. I think everyone got it. So we take the square root of 25, and that equals 5. So it's going to go in the first spot for each bracket. Then we'll go square root of 49y squared. Square root of 49 is 7. Square root of y squared, which is y by itself. So 7y goes into the second spot for each one. Okay, so the next one's going to be similar. There's just one extra step where we have to common factor out something first, and then we can do a difference of squares. Okay, so we need to common factor first. So if we're looking at 5x squared and 125, what is the greatest common factor? Is that 5? Perfect. Because 5 can divide into 5 and 125 an even number of times. Okay, so remember when we do greatest common factoring, you put the 5 out in front, and then in brackets whatever is left. Okay, so 5 squared divided by 5 5's cancel out, and you're just left with x squared minus 125 divided by 5 is 5. Okay? The reason we can't do difference of squares here is because, can anyone on your calculator just tell me what the square root of 5 is? What? No, it'd be the square root. 5 is like 2.2. 2.2.
3.6.
Yeah, a whole bunch of decimals, okay? So we can't have decimals. Even if it was just 2.5, you can't do that because there's decimals, okay? So it has to be whole numbers. So once we get factor the 5 out, then we have a perfect square with x squared and with 25. Okay? So the square root of x squared is x. I did this one a couple of times. Square root of 25. Square root of 25 is, look at the question above it. 5, perfect. So now, remember to keep your 5 out in front. And then we'll have our double brackets with a minus and a plus. Okay, and x goes into the first spot for each of them. And 5 goes into the second spot. So that will be our final answer. So we have 5 times x minus 5 times x plus 5. Okay, like when we were doing FOIL, whenever we did ones like this where it's a minus and a plus with the same numbers inside, it was wound up with 2 numbers. Okay, so that's why we're kind of doing difference of squares before when we were spinning them out before we actually talk about factoring them. Okay, now f, we have to common factor again because square root of 2 is like 1 point something. Is it 1.7 or 1.3? Something like that. 1.4. So square root of 2 equals 1.4. So therefore, common factor. Okay, I think 18 would also be a decimal. Okay, but we can't have decimals. Don't like the decimal. So what can we common factor out of 2 and 18? 2. I've heard a couple of places. Perfect. We can divide by 2 and divide by 2. Our 2 goes out in front. And whatever's left, we put inside a bracket. So 2 divided by 2 would be 1. Perfect. Minus 18a squared divided by 2 would be, sorry, someone said it. 9. Perfect. 9, and then we still have a squared. Now, if we take the square root of 1, that equals 1. And the square root of 9 would be, put into your calculator if you want. 3. Perfect. So now remember, keep that 2 out in front with minus and plus. So our first one was 1, square root of 1 is 1. Put 1 from 1 into the first spot. Oh wait, sorry, that's a squared plus 3a. Okay, so I'll either tell you that it'll be factor using difference of squares, or if you have like 2 numbers together with like a squared, that's going to tell you that it's probably going to be squared. You might have to common factor it. Not sure how mean I want to be with the test. Okay, so now we have a word problem. The area of an envelope is represented by 225 minus x squared. We want to factor the binomial to come up with an expression that represents the length and the width. Okay? So remember, like you had on your quiz, we have a rectangle, and the area equals 225 minus x squared. So we want to find our width and our length. Okay, to do that, we can factor the area because area equals length times width. Okay. So if we factor 225 minus x squared, we'll be able to find out what our length and our width are because it'll be something times something else. Okay, so area equals 225 minus x squared. Okay, so this is a difference of squares because we have a subtraction here and you have an x squared. So we can check with our calculator. What is the square root of 225? 15, perfect. Okay, so it might not look like it's going to be like a nice number, but it works out to a whole number. So we're going to be good to go with our difference of squares. So the square root of x squared will just be x. Okay, so our area, can do brackets with a plus and a minus. So our first number is 225, so we're going to use 15. 15 minus x plus x. You write that. Because that one works out to a whole number. Okay, so remember, when we have two brackets side by side, what we're actually doing is we are multiplying, right? So we have area equals 15 minus x times 15 plus x. And our area is length times width. So I could say that my length is going to be 15 minus x. My width will be 15 plus x because they're multiplying together. Okay? So all of this has to equal L, and all of this has to equal W. That makes sense. Some people are struggling with that quiz, okay? So therefore, my length equals 15 minus x, and my width equals 15 plus x. Yeah, can you put them up here? This is 15 minus x, and this one is W over 15 plus x. Okay, so now I want to find the actual dimensions if that's equals 2 centimeters, okay? So when I say actual dimensions, I mean I want like a number, okay? Right here. Plus. So I know that my length is 15 minus x, and my width is 15 plus x. Okay, so now I'm saying that x equals 2 centimeters. So what I'm going to do is I'll rewrite length equals 15 minus, but then instead of minus x, it's going to be minus what? 2, because x equals 2. Look over here. Width equals 15 plus. Instead of x, I can write 2. Because x equals 2. That 2 goes there, and that 2 goes there. Okay? People are struggling with this on the quiz too. If I say that x equals 2, just put the 2 in where the x is. They're the same thing at this point. Okay, so then 15 minus 2 would be 13. Perfect. And 13, it'll be centimeters because that's what we were given in the question. 13 centimeters. Good. Cute. That's my last. Okay, you got to break your quiz today, though. I remember. Yeah.
If you're done your lesson, can you just start?
Yep. Okay, guys, don't talk. You're both writing a quiz. Then 15 plus 2 would be what? 17. So my width is 17. So the actual dimensions are 13 centimeters and 17 centimeters. Those are what the actual numbers are. So only if you count factor.
No precision.
Yeah.
Just what we go.
All we have to do is count factor. Yep, so just kind of do it right. But only there comes back. Okay, last thing for today, we want to find the area. So we know that the width equals 17 and
You're good. It didn't work.
didn't want to work. Oop. Hey, bud. What's this? No, it's the lesson for today. Your notes. Yeah. Okay, so remember, area equals length times width. Now we sub in our length and our width. So we have 13 times 17. Wait, shh, did anyone do that in the calculator? 221, thank you. So it'll be 221 centimeters And remember, for area, our units are always going to be squared. So it'll be 221 centimeters squared.
How come the area isn't 225?
There isn't 225 because it's minus x squared. So what we could do, instead of calculating it this way, we can take our area that we had up here. Area equals 225 minus x squared. Well, 225 minus x was 2, right? 2, so minus 2 squared. So then we'll have 225. We have to do the exponents first for bed mass. 2 squared is 4. So 225 minus 4. So then area equals 221 centimeters squared. Okay, so you get the same answer either way. So it's because of the minus x squared.
Thank you.
Okay, so that's also a good way if you want to double check your work. If you find the actual dimensions, find the area that way, you can sub in x equals 2 back into that original equation, and you should get the same answer for each of them.
Yeah, only at the end.
I'll put it back up.